Have you ever used a vending machine? Press a button and out comes your snack. That's exactly how functions work in math. A simple rule that connects the input to the output. In math, a function is a rule that takes the input, processes it, and gives you the output. Let's assume the rule is add 5. So, an input of 2 would give you an output of 7. But functions aren't just rules and numbers, they are everywhere, from calculating expenses to predicting trends. They help us solve real world problems. So, are you ready to master functions and unlock the secret behind these magical rules? Let's begin. But before we do not forget to like, share, and subscribe to our channel. Welcome students, welcome to today's class. In this class, we are going to start a new series in which we'll be covering the entire syllabus of Add Maths. So today, we are going to start off with the first chapter, and that is going to be functions. So let's begin. Alright, so first thing, what is a function? The definition says a function is a rule that associates each element of one set, right? This is important, with only one element of a second set. All right, it is possible for more than one input to have a same output. Now let me just explain using the diagram. The definition said that each element, all right, is associated with only one output, right? So the left, like this oval shape, the left one will be my input and the right one will be my output. Now why have I written x and fx? Let me give you a basic example. This is you can write it like this or we can write it like this also, right? Correct. Okay, now whenever you input some value of x, right, you get some value of y. Yes. All right, on substituting, or you can say on putting a value of x, we are getting some value of y, right? So I can say that the value of y is dependent on the value of x. So this x will be my input value and this y will be my output value. Now why am I calling it as an output? Because it is depending on the input values, right? So and this y is nothing but f of x. All right, so these are the x values and these are the fx or the y values. We can even write y here, right? All right, now if you'll notice, each value of x has only one, like corresponding value of y, right? Each value of x has only one arrow leaving from it, right? So 1 is corresponding to 1, 2 to 4, 3 to 9, 4 to 6, 5 to 5, and 6 to 6 again. Okay, this 6 has two arrows coming towards it, right? But it is observed that every number on in this left portion has only one value and one arrow leaving it. That is the most important condition to be a function, right? Everything that is on the left hand side, or I can say every x value, should be only one time, right? Or each value of x should have a different, should have only one image. You call this image, right? This number or this part is known as the image, right? So each value of x should have only one image, only one image. That is my condition to be a function, right? Whether an expression is a function or not, it is defined using this condition. Every x value should have only one image. All right, Please note it down, just make these diagrams roughly and make these arrows just for your understanding. Moving on to now, what is a domain and what is range? Honestly, I have already explained it to you, but let's just understand it again. Let's write a general linear equation, right? Okay, so now what is a domain? Domain are the values of x for which the function is defined. Let's read the definition also. The domain of a function is the set of all possible inputs. That's what I just said. The possible values of x for which the function is defined. We can never say all values of x, right? The possible values of x, this is the word possible means what? Possible here means the values of x for which the function will still be defined. Let me give you an example. Right now, I have to figure out for what value of x will this function be undefined, right? If I'll substitute x as 2, if I'll substitute x as 2, I'll be getting y as what? 1 over 0, which is a not defined or an undefined quantity. So I can say that my domain will not have 0 in it. Oh, sorry, will not have 2. Will not have 2 in it. It can have any number other than 2, right? So that's how I will figure out the domain. Let's continue. This is the set of values of x that the function operates on, right? The same thing I did here. I tried to operate this function on x equals to 2, but I can't do that because the function will be undefined, right? If no domain is given, it is assumed to be all real values of x. This is often denoted by capital R. Capital R is the sign of real numbers, right? If the question does not give me the domain and the function is like defined at all the places, I'll say that fine, my domain is set of all real numbers. All right, now coming to the range. Range is basically the output. We will call this the input and this one will be the output. Now let's read the definition first. The range of the function fx is all the possible output values. See, right? So all the possible output values is known as range. That is the corresponding value of fx. Obviously, the corresponding means when we'll substitute some value of x, the answer that we will get will be known as the range or the output, right? It is sometimes called the image set and is controlled by the domain. See, all the things that we just learned, that it is the image, and that's what we wrote here, right? The image. This fx is known as the image of x, right? Okay. Now, and is controlled by the domain means what? Obviously, when we are substituting some value of x, the answer that we get, right, is the range, and that answer depends on what? It depends on x. That is why it is said that it is controlled by the domain. Please write down these definitions. Pause the video if it's taking you too long, but please write them down. Moving on to the next one. All right. Next we have mapping. So what is mapping? Basically, whenever a function is given to us and we draw this thing, right? This is known as mapping of a function. So whenever we do this, we need two things. We need the function, and that is given to me, that is fx equals to x square plus 1. The second thing we need is the domain, and the domain, yes, it is given to me again, that is from -2 to 2, but on the condition that it is only set of integers. All right, now what I'll do is, first I'll plot the input or the x values this is my x, this is my fx, right? So first on the left side I'll map the x values, that is -2, -1, 0, 1 and 2. Now to get the y values, what I'll do is I'll pick this value and substitute it in the function, right? So what will I get? I'll get f of -2 equals -2 squared plus 1. On solving I'll get 5. All right, see, next I'll do the same thing for -1 and I'll get 2, and I'll continue this process for all the values of x. So after plotting I'll just join the corresponding values of x and fx. -2 gave me the output of 5, so -2 is joined with 5 and so on, right? Now notice that every input value has only one output, right? But the same is not true. The output values or the images have, more than what I can say, one image has two separate inputs, right? For example, 5, that is the output, right, has two different inputs, that is, let me use a different pen. Yeah, that is -2 and 2. For both of these inputs I am getting the same output, right? But my definition for a function was every input should have only one output, and that is still true, right? So that's called mapping. Now what you can do is you can pause the video, take a separate example, take anything, right? You can take 2x square minus 1, all right, for same values of x, and you can plot it, map it and check how well you are able to do that. All right, so let's start. I hope you were able to do this. Moving on to the next one, that is types of functions, right? So broadly we have four types of functions: one, many, one many and many. All right, so let's study them in detail one by one. What are one functions? The name itself is going to tell me what kind of a function it is. One, right? So one means one input to one output, right? So each input will have only one image, that will be known as one, right? So if you will check, I have taken some random values because I didn't want to make it a specific one. I have taken these dots just as a representation, and if you'll notice, each dot is imaged or is corresponding to only one output value. So this is an example of one function. In a real life example, this equation, or not just this equation, any linear equation is an example of a one function, right? So if you'll notice, for each value of x, right, what I have done is I have drawn the sketch, or I've drawn the graph of this, and I'll notice that for every value of x I'll get a like a different value of y, right? So that's what my one function looks like. All right, not just this, even a cubic equation, right? X cube plus 2, let's say, this is also an example of a one function. For every value of x you are going to get a separate y. All right, so please note it down. All right, make sure for every function you are putting down the heading, you're writing the definition, even if not the whole definition, just the crux of it. All right, and you're drawing this, you're making this mapping thing. It's very important. All right, okay, moving on. Next function, that is many to one. Now whenever the name is written, right, what I'll do is this second number will be for the input and this for the output, meaning one input, see, every x value has only one arrow coming out, going out, right? And many here means for outputs there will be many arrows coming towards it, meaning for one output there are more than one input values. Okay, an example we just did in the previous one, you can take this value y equals to x square, right? For more than one value of x, you are going to get same value of y. All right, so this is an example of many to one or many one. You can call it many to one or many one. Fine. All right, an example I just gave you, I have written another one here, that is y equals to x square minus 2. Now carefully listen here. For let's say this value of x and for this value of x, right? For both of these values of x, what is the y coordinate? 0. It's same, right? So there can be multiple answers. For example, this one, right? What is the x coordinate? Minus 3 and 3. So this point is what? Minus 3 comma 7, and this one is 3 comma 7. So for both these x values I am getting the same output. So again this gives me basically all the quadratic functions are an example of many to one. All right, please note it down. Moving on to the next one, that is one to many. So one to many, basically there will be at least one input that will be having more than one output. And see, the definition goes as this: there is at least one object, or you can call it an input, that has more than one image. All right, but every image comes from only one object, meaning there will be at least one input value that will have two separate outputs, right? But every output will have only one input. See, every output value has only one unique input value, right? No, I won't say unique, but yes, every output has one input only, right? So that's an example of one to many. An equation is y square equals to 2x, basically the reverse of many to one, right? Many to one, I took the example y equals to x square. For one many, I'll take x equals to y square, and this will give me one to many, because for two different values I'm getting basically for single value of x, or for one input I am getting two different outputs. Just remember this thing: in many to one, or sorry, in one to many, I'll be getting at least one point in which I'll be having more than one output for a single input. All right, note it down. Next, many. Now, as the name suggests, there is at least one object or one input that has more than one image, and at least one image that corresponds to more than one input. Basically both the conditions will be satisfied, right? So see, this one, this input, there are two arrows coming out from it, right? And this output, there are two arrows coming into it. So basically I can say that a many function is a function in which there is an input which has at least one input that has two outputs, or you can say more than one output, and similarly there is at least one output value that has two inputs. All right, an example is a simple circle, right? See, you can take any points. I have drawn this diagram and this rectangle just for that purpose. See, if I take this vertical line, right? So for two separate for a same x value, I am getting two separate y values. And if I'll draw this horizontal line, I'll be getting for a same y value, I am getting two different input values. So both the conditions are being met. All right. Okay. Note it down. Moving on to the next one, that is types of functions. Basically, these are just some points that we need to remember when we are talking about functions. Now, all one and many one are functions. This is very important, right? Every expression, or you can say every one and many one will be a function, right? But what were the other two? One many and many. These two are not functions. Again, moving back to the definition, the definition was a function is a one in which every input has only one output, and in both of them we were having the condition was not being met. All right, but in these two, yes, the condition is met. Next point says all linear, quadratic and cubic expressions are functions. All right, this is the condition. All linear, quadratic and cubic. When I'm talking about the quadratic, I'm talking about the expression y equals to x square, not x equals to y square. This is not a function because this was an example of one to many, right? So when I'm talking about the quadratic, I'm talking y equals to x square kind of thing. All right, and cubic again y equals to x cube kind of thing. All these are functions. All right, next, a circle is not a function, very obvious, because it was an example of many. Trigonometric ratios are functions. All right, I'll give you a very simple way. I think it will come in the future slides also, but let me just give you, it is known as vertical line test. Vertical line test. Now what is a vertical line test? Basically, if I have been given a graph of a function, right? Sorry, if I have been given a graph of any expression and I need to figure out whether it is a function or not, I'll use this test, that is vertical line test. Now what does it say? A vertical line test says that if in a graph, right, if in a graph at all the points, if I draw a vertical line and that vertical line passes through only one point of the graph, then that is a function. If you draw the graph of y equals to x square, anything, right, x square minus 2 or whatever, the graph looks like this, right? And if I'll try to draw a vertical line from any part of this graph, right, the vertical line is going to pass through at max one point. It might not pass through the graph, but even if it will pass, it will pass on at only one point. Or I can say that the vertical line will intersect the graph at just one point. This is known as vertical line test, and this test gives me a perfect idea whether a given graph is a graph of a function or not. All right, please note it down. All right, students, so that's it for this class. I hope everything got cleared. So please do like, share and subscribe to our channel, and let's meet in our next class and we'll be continuing this chapter. Till then, stay safe and keep practicing. Thank you. If you had a blast watching, give us a thumbs up, share it with your friends and subscribe our channel to stay updated on all our future videos.